Automated testing is nothing particularly new in the tech world, but in the last decade, advancements in the internet and cloud technology have led to a booming increase in the availability of more complex and low-cost automation software. These days, the ability to streamline QA testing through automation has become more of a necessity than a luxury. My name is Jack, and I'm a consultant working within RadixBay's Testing Center of Excellence. Over the next 5 minutes, I'm going to discuss just a few of the tools we use to build effective test automation, and provide a brief demonstration to give you just a small idea of what automated testing could do for your company. Now, automated testing can be performed with a variety of tools, but in this demonstration, I have the automation scripts built using Selenium, Cucumber, Maven, and Java. I'll mainly be discussing what Selenium and Cucumber do, but I will briefly summarize how Maven and Java factor in as well. Java is what I use personally to write automation scripts, but as you'll see in a few moments, it's far from the only language that can be used. And all you really need to know about Maven is that it is responsible for managing project dependencies and condenses and efficiently compiles the build process to allow automation to run. Selenium is a free, open-source automated testing framework used to validate web applications across different browsers and platforms. Selenium operates on Windows, Mac, and Linux, and tests can be carried out using virtually any browser. Selenium test scripts can be written in a variety of programming languages as well. These include Java, Python, C#, PHP, Ruby, Perl, and .NET. It can also be integrated with tools such as JUnit to manage test cases, and TestNG to generate reports. The inclusion of Maven also allows integration with Jenkins and Docker for continuous testing. Cucumber is a testing tool which supports behavior-driven development, or BDD for short. It allows tests to be constructed through a simple plain English text language called Gherkin. This simple approach allows business requirements to be more easily communicated to the developers, and also benefits the client to better understand the technical aspects of the software. To put simply, anyone in the organization will be able to understand how the software behaves. Now, let's see the automation in action. To illustrate how much more efficient it is to automate testing, both a manual and automated version of the tests will run simultaneously. We'll let the manual test run in the background for now so you can get a better view of the automated testing. I have the screen divided into 3 sections here. The top left section displays the browser as automation is running through it. The bottom left section displays the custom Maven console output that I wrote to describe each test step as it's being performed by the automation. And the panel on the right provides a high-level summary of the tests being performed in time with the automation. You are now witnessing automated testing being performed on a training website that developers can use to learn how to write automated test scripts. It features several of the standard functions that can be found on any modern HTML web page, as well as advanced JavaScript tools, making it very handy for demonstrations such as this. Final runtime to perform these tests with automation is about 54 seconds. But at this point, manual testing is only about halfway complete. Let's just go ahead and speed this along. Manual testing concluded in 1 minute and 48 seconds. Doing the math, it took the automation almost exactly half of the time it took for manual testing to complete. Now, 54 seconds might not seem like a lot, but keep in mind, this was a very rudimentary set of tests being executed. The scale of your site and the features offered by it will ultimately determine the increased efficiency of automated testing. As test scenarios increase in size, efficiency will as well. Where a 2-minute test can be cut in half through automation, a 2-hour test can be cut down to 20 minutes, for an overall boost in efficiency of 85%. Now, as nice as it would be to imagine every test run executing perfectly, It's inevitable that errors with automated testing will occur, whether because of a coding error with the script, or the automation actually caught a fault with the site you're testing. In either case, when these errors occur, the script will crash, terminating the tests. The next step at this point is to determine the fault. You could just look at the failure trace to find it, or you could do what I did, and prepare custom failure output to provide more specific details. Here's how I've got mine configured. Here you can see the automation crashed while attempting to validate text. My custom output states a reason for the failure, the text it was expecting to find on the page, the text it actually discovered, the exception type, and associated message. Through the inclusion of TestNG and JUnit, I also have reports generated after every test run. The report will list every step from each scenario run, indicate at which step a test failed, and provide error details on the failed step. In conclusion, it isn't hard to tell that automated testing provides a number of significant advantages over manual methods. Right now, you can visit my blog at www.radixbay.com/testingautomation to view examples of the source code written for this demo. If you'd like RadixBay to help you set up your own automated testing environment, or assume ownership of your testing projects, please visit RadixBay's website at www.radixbay.com/testing center of excellence. RadixBay's Testing Center of Excellence combines a team of expert specialists with the latest tools, technologies, and best practices to streamline and improve the quality of application testing projects. Thank you for watching.